Am I audible?
Yes, sir.
Yes, sir.
Okay. So I started in my last class some overview of some of the concepts of operating systems, but it was there were a lot of interruptions in that class. So in this class, the main objective will be to uh, talk about how Linux and Unix are related, because that is one. So there are different operating systems that are available, but we'll be focusing in our discussion mainly on Linux or Unix whenever we talk about the internal implementations or the algorithms. And today the main focus will be to talk about some of the basic commands of Unix or Linux systems, and see that how we can identify the process and what are the different features of a process in a system. So that will be the outline, and if there some time permits, I'll talk about the overall say introduction of operating system, which I think Animesh he has already covered it, but it will again I'll try to revise it in very brief so that some of the terminologies that I'll be using you can relate those terminologies later on. Okay, so operating system, we all know that what the purpose is and what are the functions of an operating system, but uh, when we talk about OS, like in the late 60s, or in, as you can see here, 1969, there was Unix V1. V stands for version V1, and which was written in assembler language, right? So PDP-7. So PDP is the kind of CPU. So there's assembly level language, and the entire operating system was written in assembly level language. So do you have any course in did you take any course in microprocessor this time? Did you have any course in
Yes,
microprocessor?
sir. Yes,
Right.
sir.
So I think you are familiar with some of the assembly level language, right?
Yes, sir.
Yes, sir.
To add the
Yes.
values, you can store the raw operand values in some register, and then you can call a assembly level instruction, say add, uh, and it will add it. So although it deals with registers directly with memory, directly with the values that we deal with, but at the same time, I mean, it is more flexible, but it becomes difficult to recall all those assembly level instructions and their specifications and all. So although it was written in the very first attempt, and it quite well succeeded, but as you can see that later on it was immediately converted to I mean, the same thing were rewritten in C language. So those days C was a very popular language, and in fact it still exists these days also. So in early 70s, there was a version 3 of the Unix, which was written by Ken Thompson. Okay, and it was in mid 70s when AT&T and Bell Labs US, so they took charge, so they took interest, and they I mean, one of the threads. So it was a primitive version of the operating systems which people used those days, and it was not like we had desktops and all those or I mean laptops were not available those days. So it was mostly written in labs or in big organizations, and then in 76 AT&T Bell Lab took some charge, and they continued to modify and to come up with different versions, as you can see here, uh, in their labs. At the same time, UC Berkeley, they also took interest on rewriting operating systems which are more user friendly and which supports more and more features, and then that got published as BSD, Berkeley Software Division Distribution. So it was better known as BSD. And then BSD also, there are different versions that were available, and one stable and very popular version was 4.3 BSD or 4.4. And at the same time, parallelly, Xenix, which was an organization and which was, they also took their own route, and they developed in their own way modifications or modified versions of Unix, and that was Xenix 2 and all this. And then later on it was known as SCO Unix in early 80s. And then at the same time, this Bell Labs, they had their own distributions and own modifications. And then version 3, it was another. So these boxes indicate some stable and popular version of Unix that were available those days in the market. So it was version 3, and then version 3 and this BSD 4.3, that was taken up by IBM, which actually commercialized an operating system called AIX in mid 80s. And then Sun Microsystems also, they developed, they took this version and they developed of their own, and that was SunOS. So there are many, as you can see, apart from UC Berkeley, there are many other organizations or companies who wrote Unix those days, and they all were, they are having their own features and some modifications on the basic version of the Unix. And this SVR4, it was a very well-known version, and there are many say interface calls which are supported by this, still been referred. So in late 80s it was there, SVR4. And then Sun Microsystem provided Solaris, and this Linux which we use these days, it was first written in early 90s, 1991, by Linus Torvalds and University of Helsinki. So he wrote it taking the help of this SVR4. Okay, and then so this was a part of, as you can see, so these versions are all grabbed by those organizations. And then Linus thought that why don't we come up with some open source, and in fact in those days, in mid 80s, the open GNU project started, the free software movement started with activist Stallman. And then in 85 90, so there are major softwares which were made open source, and people can contribute and they can use without any extra charges. They can use to develop applications. And then in 1991, this operating system, Linux operating system, also added to that to this movement, you can say. And it was released under GNU public license, GPL, and it was released in the internet. So these days what Linux we are using, it was some form, a modified version of the primitive Unix that was written in mid 70s. And so this was still commonly used. So when you talk about some of the system calls or some of the commands of operating system, will be mostly referring to Unix and Linux. So when we talk about Unix, again you see that these are the two major versions. One is BSD, another is SVR. So there are some changes, I mean some differences in terms of the output or in terms of the say programming interface of these, but Linux is also there. So regarding the books, one book that I'll be following is by Maurice Buck, while I talk about the internal implementation of some of the algorithms, how to create a process, how to send a signal to a process, how to synchronize among processes. So I'll be referring to that book, and that book was written in mid 80s. So you can guess that that book is not going to refer anything that is Linux, because it was mostly talking about Unix internals. Okay, but regarding Linux, there is a good book by Stevens, Beginning Linux Programming. So those, I mean, these two books, I'll share it. The soft copies are available, and we'll refer to actual Linux or Unix as and when required. So first thing is, what I would like to summarize, this Linux is basically philosophically it is same that of Unix, but definitely there are some small changes which will refer as and when required. Okay. And when you talk about an operating system, say it is also a set of softwares that takes care of memory management, CPU management, or process management, IO management, file management, and all. So there is a core of operating system. Okay, so all the modules which lies the core of it. Apart from the core, there are some interfaces or some applications on top of that. So this core is known in different terms. Sometimes it is known as the supervisor. It's a generic term. Supervisor means the software which supervises the functioning of the entire system. It is sometimes known as the monitor also. When we talk about the batch OS. Now, what is batch OS? What is time shared OS? Maybe in the next class I'll give a brief overview of that, and maybe that Animesh also gave some introductory concepts on it. So the supervisor, which is a generic term, is sometimes in some particular ways it is better known as monitor, and in case of Linux or Unix, we would prefer to call it as kernel. Kernel is the most essential components of the operating system, without which the operating system cannot exist. But in the periphery, you can think of there are other application kind of softwares or the interfaces which also these days are a part of operating system distribution. And Windows, when you talk about Windows, the core of Windows operating system is better known as executive. So these are some terminologies. So whenever from now onwards we say kernel, kernel means the core of the operating system modules that controls the different resources in Linux or Unix. Now, we already found that, I mean, in our last class, and I think meanwhile, Animesh also has discussed about process. So what we also discussed that a program, when we compile it, we get the object code, and when we run that object code, we create a process, and the process manifests its existence by grabbing some resource, maybe some memory resource, some registers, some other data structures which is required to maintain it, like that. So that is how it manifests its existence, and during its entire lifetime, the process it changes its states. So there are some predefined and well-known states in Linux or Unix. We'll see that, and whenever some activity happens or some event happens which the process is related to, its state changes. So it was like the student, first year student, second year student, second year backlog, second year, so whatever. Okay, so as the state changes, so the operating system need to keep track that what state a particular process is in. So it defines explicit states. So before we get into all those details, let us see that how a process gets identified in the system. So first of all, as like student IDs or student say registration numbers, a process which is created or a executable file, when we just trigger it, a process is created and it gets a unique number which is not same as any of the rest of the processes. Okay, and that what we call it as the PID, the process ID. Okay, so this process ID, it is quite intuitive to understand that every process will have a unique process ID which is better known as PID. Okay, and so it's a system-wide unique ID, and these days we use 64-bit machines, and earlier you used to have 32-bit machines. So depending on the type of the machine, 32-bit or 64-bit, you have got a maximum limit of how many processes you can accommodate in the system. Okay, so because it is a 64-bit machine, so these days the limit is 2 to the power 22. So it's almost like nearly 4 million processes can be accommodated in a typical Linux systems. Okay, and earlier the limit was this, and it was like 32,768. So those primitive Unix or Linux systems, they used to accommodate not more than say 30-40,000, but these days it is almost like several millions. And it is indeed true that multiple processes can coexist in the system without conflicts, because the operating system monitors who is going to share which part of the memory, who is going to grab the CPU for how long, and who is going to access the IO. So all these are monitored and in a nice and fair way by the operating system. And there are policies, well-defined policies and algorithms which takes care of. Now, what is the value of PID, or the maximum limit of the PID? That if you want, you can check this. You can get into this particular location, and you can check the PID underscore max file, which will give you the maximum number of processes which can be created, which can exist in a system at a particular point of time. Okay, and so when we boot the system, when we start booting, say maybe the booting is it may be a Windows operating system, it can be a Linux operating system or a Unix operating system. So if we talk about Linux or Unix, whenever we boot, what happens? So definitely the entire operating system, all the files will be in the hard disk, and when you start booting means from the hard disk some image, boot image of that will be need to be loaded in the RAM, right? Because without having instructions in the RAM, nothing can execute. So even for the operating system, a small portion of the operating system which was originally in the maybe in the boot sector, so that image will be loaded in the RAM, and once it is there, now from there on, so there will be one by one the instructions which gets executed, and that in turn loads the remaining portion of the say some portions of the operating system in the RAM, and then the whole machine becomes ready for user commands, for accepting user commands, or say user activities. Now, so definitely in this process you can say that there is one process which is a primitive process, which is the first process that gets created in the system. So after booting, the first kernel process, because kernel means we are talking about Unix or Linux based systems, so you prefer to use the term kernel. So the first kernel process is having the PID 0. Okay, so the counting starts from 0, but the first process gets started is 0, and which creates, and that in turn creates some other required process, so that you can start typing a command, or you can start clicking a so maybe the GUI gets created and all this. So once this process 0 gets created, then that in turn creates another process which is which you can say it's an initial process, or it is called the init process. It's better known as the init process, INIT, and it has got the PID 1. Okay, so this is the first user process, user level process that gets created. Okay, so this PID 0, it is a system process. So now there's a clear distinction between system process and user level process. So system process means what? The operating system itself comprises of multiple programs or multiple codes, and maybe operating system does not mean a single process, rather it will be a collection of processes. And whenever the machine becomes ready, now if I run my application, so that application creates a user level process, because I am a user. So you can have multiple system level processes, you can have multiple user level processes, and there can be say myself as a user can create some processes, you as a user can also create some processes in the system through remote login. So the first user level process is INIT init, and it has got the PID 1. Now this init process, because so this is the process 0, which is anyway the first process, the trivially first process, but the first effective or useful process is process 1, PID 1, and that from that PID 1, the rest of the process all they are rooted to that init process. And so once the init process is created, you cannot as a user you cannot immediately start typing commands to get some things executed. So this user process in turn it creates a terminal process, right? So once we have the operating system running, I mean earlier in those primitive days we don't used to have the GUIs, but these days it is all a GUI enabled interface, the desktops and all. But earlier the Linux was you just have the shell, and that shell prompt is there, command line prompt, and from the command line prompt you have to type commands to get things done. So the first thing is that the init process creates is a terminal process. Okay, terminal means those that small box that gets displayed with the prompts and all this. And this is
See how amazingly we can actually use the GitHub Copilot. And
somebody's switched on the audio. Please switch it off. You mute your speakers, microphones. So the init process creates the terminal process after the user logs in. Okay, and this is this terminal then accepts commands from the user, and through that the user process gets created. Now this terminal process is also important because it in turn executes a shell process. So how many of you heard the term shell in the Linux, in the context of Linux or Unix? What is a shell? Shell process?
So shell is the terminal for Linux.
So you have the terminal process, and the terminal process in turn creates a shell process. So this again, it's basically a terminal, but in that shell, the shell is something which will accept your commands. It will check that whether the command is correct or not. Okay, for displaying the directory, or for copying a file to another, or for switching the directories and all this. So there are different commands for this. So if the command is correct, then it will trigger that the code corresponding to that command, it will execute it. If it is not, it will display error message. So the shell, it is not only capable of executing simple commands, but it can also execute scripts. Okay, shell scripts. Maybe that many of you have heard this term. So the shell scripts are they looks like it's a collection of commands, and you can have put some extra logic into it. So it is not only just you write cd or pwd or sorry, ls. You can have a combination of them, and you can have a if else statement and all this. So a shell script is even more better if you can write a shell script. So the shell is meant for executing shell scripts or raw commands, or single commands as you wish. Okay, and for Linux there are many options or many types of shells. One is the bash shell, that is a GNU born shell again, born again shell. So GNU shell means that is an outcome of that open source movement in that started in mid 80s, as I mentioned. So that was a bash shell, and it's a default shell, and all the Unix and the Linux also, when it was written by the creator, so he used this bash shell. And most of the Linux distributions, it come up with sh, ksh and csh shell. So that is the Bourne shell, corn shell and C shell. In fact, so there's a default shell, and when you use it, maybe we use the Bourne shell, but sometimes if you want, you can change it to some other shell also. So all the shells, they will have some difference, subtle differences, but their main objective is to execute scripts or single commands. Okay, so the thing is, to summarize, when we boot the system, first the process, the kernel process PID0 is created, then that in turn creates an init process with PIDI, that creates a terminal process, and the terminal process creates another, like this shell process. Okay, and once you have the shell, now you are ready to input prompts. So as I mentioned, that the shell is it is capable of accepting some commands, and some of those very simple commands are pwd, ls and cat, and maybe some of you already have used it. So first thing is, if you have not, so how many of you have not installed Linux in your laptops or desktops? Is that all of you are having Linux in your machines?
No, sir.
No,
You
sir.
are sir.
No,
Yeah,
sir.
so
No, sir.
those who do not have, so they have to make arrangements to install Linux. So Ubuntu Canonical, I have installed it, so that you can so having Windows, you can install it, or you can have some other types of Linux distributions. You can have a separate partition for doing that, but you have to have Linux installed. So that I hope that within a
Sir,
couple
can
of
we do it by git bash, because we have
Yes, somehow I would like to have a Linux shell where you can type commands, and also you have to write some system programs. I mean, using some system calls. Okay, so it is better to have Ubuntu Canonical, which will have all the features, but you can also have some other, you can create a partition, you can do it. But maybe by within a couple of days, you try to, those who don't have, try to have some uh, distributions of Linux. And Ubuntu, it will be the same that I'm using. You can have something else also. Okay, so the shell commands pwd, it stands for prints the current working directory of the user at present and displays a complete path starting from the root. I mean, the slash stands for the root, and from the root it has got subdirectories. So so this is one example. So home underscore Subroto and code, so that is, so it just displays the present working directory. If you write ls stands for listing, and l hyphen L means it is for long listing, all the options are given. So it is a utility for listing the contents, the files and subdirectories of a particular directory. So in that present working directory, if you type ls underscore ls hyphen L, it will display all the subdirectories as well as files that are listed there. So as you can see here, in this example, it has got os as a subdirectory, and this a.out and hello.c are the files. And so this one is the username. So I have logged into that Linux, I mean in that Unix. So this is the username. So this is the user who is using, and this one is important, as you can see in the first column. So this D stands for directory, because OS is a subdirectory under this code, and this a.out and hello.c, these are normal files. So that's why this D is made hyphen. And you have got, see, so there are three attributes in a bunch. So this tree, then this tree, then this tree. So there you have to, there you can specify. So if it is read, means it is read only, or it is write only, or it is executable only. And as you can see, because a.out is an executable file in Linux, so for a.out, this x is there, so it is executable. But for hello.c, these x's are left blank because you cannot execute directly hello.c. So if you go for ls-l, so you can have some idea about what kind of contents are there in that present working directory. Now using this
Sir,
cat,
sir, RW, does RW stands for read write? Like we
yes,
can read and
R
also.
is for read, W is for write, and X is
Achha.
for execute. So sometimes you can read, you have the read permission, write permission, and you have the execute permission. So this a.out, you can modify it also. You can change the contents, and definitely you can execute like that. So what kind of
Okay.
permissions are set to this? This is listed here, and there is a command through which you can change the permission. So ch mode, you can change the mode, and you can reset the permissions if you want. But definitely, if you are the owner of a file, then only you can change its permissions. If you are not owner of the file, you are not, you will not be allowed to do so. And there are some files which you are not allowed to change permissions, or execute of your own, uh, which are mostly the system files. Okay, that you cannot do. But rest of the files which you have created in your present working directory or in your space, you are free to modify, update, or execute if it is executable file like that. So cat is another important command. It is just to display the content. So if I write cat hello.c, it just displays it here. But definitely there are nice editors which you can use to display the contents with nice formats and colors and all this. Okay, so another very interesting shell command is ps. So how many of you have used ps command? Anybody of you have used ps?
No, sir.
So ps stands for process status. It is a short form of process status, and it displays the currently running processes. Okay, so if I have just say started the Ubuntu Canonical, or maybe the Ubuntu operating system, and if I have not created any user process till now. So if I write here PS, just PS, it will show bash and this PS. So what can we infer out of it if it just shows this much? What this bash stands for? What is bash? I just now mentioned.
The shell.
Bond shell.
Bond.
It's a Bourne shell.
Bond
So
shell.
I mean, so the default shell that I'm using in Ubuntu Canonical is Bourne shell. But if I want, I can change it to Corn shell or some other shell, SH or whatever, right? C shell. So this is a Bourne shell. Now, in fact, you know that the Bourne. So automatically when you boot, and so ultimately the shell is created and the shell process is running. So this is basically a shell process which is running, right? And
Sir,
the PI, yes.
Difference between these shells. What's the difference? What's the difference?
Difference is different implementers. So different persons wrote these shells. More or less the philosophy is the same, but they wrote it in a different way. They might be having different commands, or maybe when you try to list the files in a particular shell, it will have a different formatting and all this. So purpose is the same. It will allow you to execute the basic operating system commands, and it will allow you to execute shell scripts. Okay, so the difference is very less, but there are differences. And I think for details you can go through the book by Beginning Linux Programming by Stevens. I think I have shared that book, the soft copy of the book. Is it there? Hello?
Yes, sir, you have shared.
Yes, sir.
It is there.
Shared.
So there is a chapter on I think shell commands or shell scripts, writing shell scripts. So there will get the difference. Okay, I'm not going to the details of it because uh, the focus will be on something else that I'll coming. Uh, so and I have asked MS to take one class on writing shell scripts, basic shell scripts. So there you will get some more idea. So this is bash, and what is this? As you can see, the PID column states that this bash shell's PID process ID is 180. So bash itself, the shell process, its shell itself is a process, and its PID is 180. And what is this PS? What is
The
this
process
PS?
status.
So this PSC, this command is also nothing but when you execute the command, it creates a process because something need to be done, executed. So this PS also spawns a process, and this is called PS. So the command, so in the command column it is written, and the PS, the PID of this process corresponding to running the command PS is 197. Okay, and both of them are running in the TTY, means the terminal. So in fact, once you boot, a terminal process is created. Under the terminal process, a shell process is created, like that. So TTY1 is one terminal, and if I create more terminals, probably it will be TTY2 and TTY3 and like that, right? So this is what it says. And then PS can be tagged with some more options like -E and F. So you can write either PS underscore, you see, PS-E or PS-F or PS-EF combined. So if it is E, means E stands for select every process here. So this is every process means, so what was excluded, if you have not mentioned -E, so what is excluded and what we mentioned but it was not there is INIT, right? INIT I just now mentioned. So after the initial system process 0, the init process gets created, and init process, in fact, that is the root of all processes, because from the init, the terminal process, the bash, and then the under the bash there are others. So like that. So that's the root of all the processes, and its PID is 1, as you can see here, right? So this init, and that init itself spawns the TTA. So this is a terminal process that gets created, and that in turn creates the shell process, and that in turn within the shell we have executed this command. So is that clear? So now it includes all the processes that currently exist in the system. So if you want to execute all the processes, you have to write PS underscore PS-E. Is that fine?
So PID 0 has been terminated after
No, so
voice gets loaded.
PID 0 is it is just a kind of, you can say it's a dummy process which is actually creating, it's meant for creating just the init or process PID 1, and that PID 1 is actually that that is tracked, and that is responsible for creating the rest of the processes. So PID 0 is just for, it's a dummy, the default process that gets created. Okay, so PID 1, PID 0 is not displayed anywhere in the system.
Okay, sir.
But from init, you can see the init exists, and init exists forever because the init is the root of all. So you cannot. So if you want to terminate, kill, forcefully terminate or kill the process init, you are not supposed to, because init is not something that you have created. It's a system process, and you cannot step in and do some damage in the system by killing the other processes. You are not allowed to. So that kind of security the operating system itself maintains. Okay, you can see it, but you cannot tamper it, you cannot terminate it. That is not possible. So if I write here ps-f, that means F stands for full output format. So full output means, see, instead of this compact format, you have got the UID, PID, PPID, CSC, all these things are there. And if you can decode it, it says that the command is this fine. And if we discuss about both combined, it will be better, I guess. So it includes all the 4 processes that I have explained just now, and it is a UID. UID means the user ID. So who was the user? So for the init process, the user is a root. The root means the system root. When it boots as a root. Okay, and then myself as a user, I try to log on and all this. So these init is a part of the root user, and this bash and ps, these are part of the user who clicked the terminal and who created the terminal and all this. And this PID, these are the unique IDs of each of these processes that exist. And can you decode what is meant by PPID? What can be the meaning of
Parent process ID.
It is a parent process, right? So you see, if you try to get something out of it, so this root, we mentioned that. So here you can see that there is existence of parent process 0, right? So 0 is the parent process ID. 0 is the it's a maybe the first process, that the trivial
process head.
and then that creates 1, and that is actually the init, and then that init again created this one 179. So it created 179. So what is this 179? This is the terminal process, and this terminal process in turn creates, you see, the shell, right? So the shell process ID is 180, and that shell, within the shell, I have created I have executed this PS. So this is again, so this is the one, this is a 200. Okay, ক্লাসে আছি আমি। So this is this 200, and this 200 is basically the PS, and this is the shell. Okay, so can you see the process hierarchy? Is the process hierarchy clear? Hello?
Yes, sir.
So so these are the processes, and the PIDs are clear, and then this is a S time. S time is the start time. TTY is the corresponding terminal, and this time is how much time they took to execute. So all these details are there, right? And you so corresponding to each column, so the contents, the interpretation of the column headers are here. So percent CPU, percent memory. So how much percentage of CPU the process consumed, how much percentage of memory the process consumed, and all this, these are not visible here. So for that we need to have a different command to get all those details. But we have the command, we have the PID, PPID, these are available here. And the virtual memory usage, that is also not here, right? But the user ID, the terminal ID, these are all here. So you can refer to this list to see what it means. By the way, virtual memory, has it been discussed in some outline has been given? What is a virtual memory and what is the
Yes,
purpose?
sir.
You know that. So this virtual memory details is specified here. Okay, so let us see some other command through which also we can see the details of a process, and this is this one. So shell command PS, but the options, instead of -ef we use the AUX, and see the difference. So it says that this options -ef, its option is used in Unix system supporting POSIX standard, right? And this is supported derived from BSD. So can you recall what BSD was? This is a BSD, the Berkeley Software Distributions. So the Unix developed by the BSD, they actually, because these are all done in parallel without too much of interaction. So they did it in their own way, then these persons did their own way, and they basically modified this version 6 AT&T Bell Labs version. So that they modified and they did it in their own way. So there might be some differences as we found, and this PSAUX, it was borrowed from BSD, and in fact, because Linux was developed trying to take the best of both, so Linux, but during Linux you can use both of it. But if you use a pure BSD, it will not probably support -ef, okay, and vice versa. But Linux supports both, so that's why in a Linux Ubuntu you can try both of these options. So where A means lists all the processes on a terminal, including those of others. Others means, so I am a user, I have logged on as say with my name, but if it was a server, it's a server machine, and if you have got the login access, you can log in from some remote machine also, okay, using remote desktop or remote terminal. So if that happens, say in that case, if I use PSA, that means all the processes created not only by me but by other users also will be visible. X means lists all the processes without controlling terminal. So now, till now, whenever we say there is a process, we say it is associated with the terminal TTY1, but it might happen that and TTY1 is probably the controlling terminal. So this is the terminal where we are typing the commands and all. So this is the control terminal. But if there is some other process which is belonging to some other terminal also, we can see this. So that option is added. And you can in fact create multiple terminals. We'll see in a short while that how multiple terminals can be created, and you can keep entering commands from each of these. And U means it adds a column for the controlling user for each process. Okay. So if I have this PSAUX, you will find that, see, the user, that was also in earlier case also, it was a PID, but there is no PPID. So this option misses the PPID option, but you can, so if you combine both of it, you can have the PPID option. Then the percentage CPU percentage memory was not there earlier, but now it is here. Then the VSZ, it is related to the virtual memory usage or some information related to virtual memory, which we'll refer later on. Then it is RSS, that is also it is the resident set size, that is also related to virtual memory. When you read in details in memory management, which will be taught by MS, you will know these two. You will be able to relate. Then TTY is known. Stat, so start is there, time is there, command is there. And what is this stat? Stat means what? Can you decode this? What this stat means?
Status.
So status of the process.
State of the process, which state it belongs to, because we talked about that a process which is alive during its lifetime, it can take many different states, but there is a defined set of states, and one of the states it will take, right? So it will specify what particular state it is. Now if a process is currently getting executed by the CPU, then it is called in the running state. So running state means it is currently getting executed by the CPU. But if a process is ready, ready means it is not waiting for any input output or anything else. It is not waiting maybe for, maybe sometimes what happens, this is a process A and the process B, and the process A is waiting for something to be sent by process B. So process B will send a signal and only then it will start. Okay. So that can be the case. So it's ready, but and sometimes it is completely ready. It is not waiting for anybody. It is not waiting for IO, but because there is a single CPU, the process is waiting. So this is called the ready state. Ready means it is ready to run, but it cannot because a CPU has been allocated to some other process by the operating system. So that is a ready state. Running means the process has been allocated the CPU and the CPU is executing some instructions of that process. And there is another state which is called suspended. Okay, so suspended means a process which was running in the CPU suddenly, because it requires input output, and input output means it will release the CPU and it will go for input output. So in that case it becomes suspended. Okay, and there are many other states. We'll discuss about it in details later on. So this STAT will show you the status of the process. So here you see this is in the running state, this is in a suspended state, and there are other meanings also which is here. And there is another very interesting state called zombie. We'll talk about it later on. Okay, so sometimes it will be written as zombie. We'll see that how to create zombie processes and what is the interpretation of that. So any question till this point?
Sir,
Sir, what is
suspended
the
essence-
notation for ready state and running state? So how do you distinguish between
So R
them?
is for running. Oh, R ready and running. No, sir,
Yes.
that depends whether the Linux or whether the operating system provides you with that facility. So this R is for running state, and S is for suspended. So theoretically, although we specify okay, so there are 7 states or 8 states, but in practice, maybe you see this is S, small s and L. So the actual operating system, Linux operating system, it has defined the states, these few states, and using this s and this small s, you can have a combination. You can have, so process as session leader, the foreground process, zombie process. So strictly speaking, the in theory whatever process states we read, actual implementation may not have one-to-one mapping of that, and may not have a status code showing that also. Okay, so
Yes.
this is in terms of Linux. So but again, when you see or when you go through say Galvin book or Sylvester Galvin book or any other books, you will find that you may not have a one-to-one matching with these two, but there will be some overlap, and you have to accept it. It's like the raw theory and the actual implementation might differ a little bit. Anything else till now? Any question?
Sir, why is the terminal number of process with process ID 1 set to question mark?
Because that is not actually running in a particular terminal. It was created even before a terminal is created, right? So that process, uh, that one init, the first one, the init with PID 1, that actually created a terminal. Right? So that's why this was a terminal. This was a terminal process. So from this onwards, the TTY1 is there, but this init was created even prior to the creation of the terminal process. Is that okay?
Yes, sir.
So let us see what happens. I think I can. Okay, I can. In just a minute. Okay, let me have these ideas. So if I you see, this is the terminal that I have created, and so I'm using Ubuntu Canonical. Okay, so I've installed this.
Sir, we can just see
Sir, we
your
cannot
home.
see the terminal.
You cannot see this.
We can just see your home screen.
I've already shared this. Now, can you see this?
Yes,
Yes.
sir.
Yes, sir.
Huh. So now, so this is the Ubuntu app, and Okay, just a minute. I'm getting a phone call repeatedly. Let me just take the call. Um, just a minute or two. Hello. Hello.
Yes.
Yes, sir, we can hear you.
Can you see
Yes,
this?
sir.
Okay. So now
Yes, sir.
this is, if I write present working directory, it shows that we are under home, Subroto, code and OS codes. Okay. And if I write ls, so see these are the files that I have created already, that is already created here. So these are all source codes, the C programs. So that's why they are not executable here, as you can see. And this dummy.c, you see the permissions are not been set properly. That's why it is all blank. So if I try to do something, it might create problem. And so what are the other codes? It is not working. Okay. And then we wrote cat. Okay, ls. So if I see dummy, see it shows permission denied, right? Because it was all hyphen. But if I now write cat, say hello.c, display something. Can you see? Hello.
Yes, sir.
Yes,
But
sir.
the previous case dummy.c, there was a so it denied access. Okay. So now let us try the ps. Is it visible? Now you see here also it shows that it is init. Init, the init, that is a PID 1 whose parent is the system process 0, and then this init, that is the maybe the terminal process, which is 6, PID 6, which is just below it. So the entire process hierarchy becomes clear, right? So now if I create, you see another, what got created here, what got created, this was one terminal,
Shell,
another terminal got created, right? So in this terminal, so once it got created, so if I write ts -ef, can you see the change? Can you see the difference?
yes, sir.
So see the 0, the PID 1 is already there, it was already there, and now so there is no change in that. But now after that, this terminal 6 got created. The terminal with TTY 1 with PID 1, say PID 6 got created, whose parent is 1, right? And then at this point of time, you see there is another terminal got created, that was TTY 2. Okay, so TTY 2 got created where this is 50 with 1 as a parent, and each of them they have spawned a bash shell. Is that fine? Hello?
Yes, sir.
In fact, somehow it got created 3. I don't know, maybe I pressed that. So there are 3 terminals that got created: TTY1, TTY2, and TTY3. And in one of the terminal, I am executing the PS this command. So in fact, this one, the third terminal. If I execute it from here, now it says that it is created. So each terminal is identified by a particular PID, terminal process, as well as some terminal ID. Is that fine?
Yes.
So now if I okay, so here so it's infinite. What is that code? Infinite loop. Okay. So GCC. So what is this code? What is this code all about?
Infinite loop.
Finite for loop.
So if I type this in infinite, so it runs. So once it runs, can you see the so this definitely has spawned a new process, right? So can we see the process here in this terminal? See, the terminal is now busy because the process is in the foreground of that terminal, and the terminal gets engaged. You cannot type anything there; it will not work because it is now running that. So how to see the presence of this new process? How to feel the presence of it? Let us switch to terminal 2, right? This is the terminal 2, and let us type here ps-ef. Can you see its presence? Can we see this? What is
Yes,
there?
sir.
Now where is that? Yes, the a dot out. Can you see this a dot out? So where did you execute this?
Yes.
TTY1, and what was the PID of that? It is 130, because after that this PS got created as a process. It is 132, and this process 130, it has got the who is the parent of that process? It is
7.
the terminal. It is the terminal resource 7. So 7 is what? It is a bash. It is a corresponding bash shell that is running in that terminal 1. Is that fine?
Yes, sir.
So now if I would like to stop that process, what should I do? It's an infinite loop, but I want to forcefully stop that process running. What should I do? Okay, now meanwhile, if I write here AUX, because I cannot see the status, right? So if I want to see the status, I can see this. You see, now it says that it's running, right? It's in the running state, and PS AUX also was in the running state when we took the snapshot. So these two are in the running state. Can you see this? Hello?
Yes, sir.
So these two are in the running state. So, but you see, these are all suspended in some form. And as you can see here, so how much CPU time this process will continue, will take, or it has taken? This process, this infinite loop, how much CPU time?
1 minute 36.
It's almost like most of the CPU time has been consumed by it, and the rest of the CPU time who consume, the rest of the CPU time might be some some of the system processes might have taken or may not have taken because nothing is running at all. Now what about the memory? It was an infinite loop. There is no memory that has been used here. Okay, so the memory usage, the memory requirement is 0. But what is this virtual memory? So even though you don't use it, there will be some virtual memory segments which will be allocated for you. So maybe I'll in the next class I'll talk briefly about it. What is this? So is that fine? So now if I would
Sir,
like to,
sir, you are also running Chrome in the background. So when you are writing PS, why
no, I'm
something
not.
about the Chrome?
No, I'm not running Chrome in the in this Ubuntu. I'm talking about Ubuntu. So Ubuntu Canonical is running, and this command, this terminal is only dealing with the processes that is running in the Ubuntu itself.
Okay.
So Windows is basically ignored. So it has just created as if you are running only Ubuntu, and the whole thing is for Ubuntu like that.
Okay, sir.
So if I consider some kind of interface through which I can see that what are the processes in the Windows, then I can see that okay, in the Windows there is a Ubuntu shell, this is a Ubuntu, another Ubuntu shell like that. So all those will be displayed. But I am talking about Ubuntu itself, and within the Ubuntu or whatever Linux I am running, it is showing that. So now my question is, if I would like to, because it is now going forever, it never stops. So if I would like to stop it, how can I stop this? How can I stop the execution of this process whose PID is 130? What my
Sir,
question?
kill 130.
Yes. What else I can do?
You can press Control C on the terminal that it is running.
So if I write here, you see, if I write here KILL 130, all of a sudden this process gets terminated. You see, so the process that I executed a dot out dot slash a dot out, it was in terminal 1. Now from terminal 2 I gave a command KILL with that process ID. I just asked it to be terminated and it got terminated here. Can you see? So it got terminated here, but the command was given here, right? Alternatively, what I could have done when it was running like this, I could have written Control C also. So that also would have terminated it. And you see there is nothing here, or if I type the same PS here, now you cannot see that particular process A dot out. It has been terminated. Is that okay?
Sir, can a particular process ID be reused? Like, can some
No,
other process be?
it is not in your hand. So again, you are trying to interfere with some policies that the operating system itself has chosen to use. So definitely the operating system has got. So you cannot ask that when you are checking into a hotel room, you cannot say that the manager, okay, I saw that that person is has checked out, so give me that room. You cannot say that. Okay, so this policy of assigning say PIDs, it is based on so it is some policies that the resource manager has chosen. So you cannot do that. And generally what it follows, so it starts from 0. So 0 is trivial, 1, then 1 it starts, 1, 2, 3, 4 like this. It goes on, and there are other system processes which also gets created. So you cannot control that. And if you created a user process and that got terminated, so that remains blank, unassigned. And it goes on and on, takes higher values till it gets exhausted. And maybe after it gets exhausted, then the process, then the resource manager will again reassign it. That is possible. Okay.
Yes, sir.
So you cannot say that I want a process with I know that this ID is not there, so I want to have a process created with this ID. Let me have this ID. You cannot do that. Okay, so now next let us see that if I
Sir, if a process is terminated, then it should the process ID is resolved or it is deleted.
No, process ID reserved means process ID becomes free now. If the process is terminated, means the process ID becomes available.
So
Be assigned
it can
some
again
others.
the PID can be like for another process, right? If the recent
That is
process
what I mean. So
terminates
you,
and
no, no, it may be may be assigned but may not be assigned. Like when you took admissions, say 100 students took the admission. Now within a week or so, 2 students left, right? And then after that, again 2 more students they took admission. Do you think that two new students will be assigned the roll numbers of the students who just now left? Do you think so?
most probably not.
Not. So here also, so OS also says that it's not done in the real life also. Why should I do this? So let me try to assign fresh values till I get exhausted with the options.
Okay, so it just checks the previous PID and increases the value, keeps on increasing, right?
Yes, that is a normal rule that it follows. But
Okay.
again, this is a policy internal to the OS. But generally for Linux, it will probably not use the something that has been exhausted till it completes the entire sequence of numbers that are available to you. And what we found, how many numbers are available in the range of 4 million in a 64-bit CPU. So it's too large and too big a number, so you don't have to bother about it. And definitely it will wrap it up. So one thing you can try, like you create a process and delete a process. So using a small code, you fork a process and delete, fork a process, and after a short while it gets deleted and it forks another one like that. So if you keep on doing this, then maybe you find that, I mean, do it for maybe the whole day and you'll find that what happens. And maybe you, so that is one way you can see that how, what is the policy that it follows. Got it? Hello?
Yes, sir.
Now if I have created this, I can terminate it. Now the point is, if I do it like this, then do you know what the meaning what does it mean? Now this terminal is become available. Now if I write here PS, can you see what happens? So can you interpret what does it mean by, what do we mean by this one? Ampersand, giving an
The idea
ampersand.
of that process.
Hmm? No,
The idea of that
ampersand
process.
means what is the difference that you can feel. Now once you put an ampersand, did you so is there any user process that got created? A.out got created, right? A.out is still running. Can you guys see this? A.out is running,
It's
right?
running in the
Yes.
background.
Yes, so that is what it means. It is running, but now the terminal is free for use. So that means it is running in the background, right?
Background.
So it's running in the background. Lot of memory problem. Okay, so still so if I check it from this also, so from here if I run one more, say /a.out ampersand. What is this? Okay, now if I run one more, or maybe one more, or maybe one more, so can you see this? What is happening? So how many user processes I have created?
So 5.
5.
Hello? 5, and each of those 5 are in the background, right? Now can you tell me that what is the association between a process and a program? So how many object code are there? There's one object code that has been saved in this present working directory, right? And that one process, how many one say code or one executable code, how many processes it spawns?
So 5.
5.
Now
Hmm?
5.
Okay. So it is something like you as a student, maybe that if the rule permits, I mean there are rules that are coming these days. I mean maybe you people will not be able to opt for it. The option for minor in, so being having a major in BTech CS, you can opt for a minor in maybe electronics in some, or maybe you can opt for a minor, getting a minor in civil, okay, minor in humanities, that is possible. So a student can having a, so what I mean to say is a particular student, so it's a physical student. Now he's a so he manifests a CSC student, he manifests himself as a CSC student, he manifests himself as maybe a EC student also if he's getting a minor in that EC, or he sometimes can manifest himself in some other form also, like that. So there's a physical entity that is a slash dot slash a dot out, but that creates through this process multiple processes. Are you getting my point? So there is a one to many association with respect to the code or the physical code or the object code along with the with respect to the process. Is that part clear?
So
Yes, sir.
one question.
So
Hello.
here,
So sir, if we give a command like kill 148 and the PID 148 is not there in our system, then what will happen?
see what happens. No such process.
Okay.
And this kill, what is this kill? Do you know what this kill is?
System call.
Kill is a command. So what is the purpose of kill? So kill is so it seems that it is to its purpose is to kill, but it is not literally to kill. So kill is meant for sending a signal to that process. Okay, so later on you
Sir,
will see
it
that
makes a system call, I think.
it makes a,
System call for terminating the process.
yes, no, system call, again it's a very vague term. What I mean to say is kill is intended to send a signal. That is your turn, so you should terminate, like that. So kill is
Like
basically
terminate forcefully, sir.
yes, terminate forcefully. So we'll see that. So kill, there is a system call called kill, and using that system called kill, you can probably a process can initiate a signal to some other process and may not be not just to terminate that. So what I say is, so there is a process say 2 and there is a process 5. The process 2 calls kill, and in that kill comma in the kill system call, it can specify this. So kill means what? Kill means I would like to initiate a signal to process 5. So kill 5, kill within parentheses 5 comma what kind of signal I would like to send. So maybe uh, if it is sigint or maybe sigabort or whatever, so it will specify the signal name. Okay, so kill, in this case it says that okay, it's kill means it's killing, but it's not actually completely true. So kill is often used as a system call where it enables a user process to send some signal to some other process. So we'll see it later on, but in this case kill, this means just terminate. And termination is also a signal, like a process is running, right? Now when you write kill 148, that means from the user, from the terminal, as a user you are requesting the operating system to send a signal to this process, to a termination signal to this process, right? So kill 148 is a command given to the operating system requesting the operating system to send a signal in turn to this process that you get terminated. The user who created you wants to terminate you, that's all. Okay, now in this process, so let me come back here, and the CPU usage, can you see the CPU usage here? Okay, PS AUX, can you see the CPU usage of each of these running processes? Hello,
Yes, sir.
Yes, sir.
Yes,
So
sir.
this is not now 90% or something near to 90. It has it is less than that. Now the thing is, if so in my laptop it is not just one physical CPU. There are multiple CPUs. So maybe 4 CPUs are there. So the thing is, they're basically sharing the resource, CPU resource like that, and the scheduler is doing that so that even if there is a one CPU, all of these are running parallelly, and they are taking turns. Like the scheduler schedules out of these 4, one of them executes for a while and then pushes out, throws out. The next one comes. So in that way, they will form a queue, all which are ready, and they will take their turns. And this is called time sharing. So it's basically the entire CPU time is shared by all the processes which are active and ready to run. Got the point? And the task, and is the task of a scheduler module of the OS to find out who should be getting the CPU next and for how long it should be executing the CPU. Is that fine? So that's why the CPU time you see is not 10%. They are all basically sharing it. And PSAUX, it has basically used only 4% of the CPU time because it's just a it will check the process data structures and find out that what are the active processes, what they are doing, and just display it. That's all. Is that okay?
Yes.
So now, so this skill is there. This is okay. So if I have some other process like what is that? Okay, infinite dynamic allocation. Let's see this. ls infinite dynamic. So GCC infinite dynamic allocation. Okay, we have not checked, I think, what is there inside. So cat can you see this? What it does? So in a for loop, it keeps calling malloc and all this. So what will happen eventually if it goes like this? At some point of time, the heap from where it gets the space will be exhausted, right? Until the point the heap does get exhausted, it will continue. Do you agree?
Yes, sir.
Can you see this? So now if I I've already compiled it. So if I execute a dot out, so this is what it does. Now in some other terminal, if I go for this one, see what happens. So I found this a dot out. Which one is a dot out? So all are a dot out, but now this one is a different one that got started me?
Yes, so now you are audible. You got muted again.
It. Not my fault. Am I audible?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So can you guess what happened?
Sick. Too much power.
That program crashed your laptop?
Yes, actually, MS team, I already had some resource problem. Like earlier last week also, it created problem. I didn't have enough memory probably. Maybe that when I'm using the heap and all this, so it just went off. The MS team got abruptly terminated. Okay, so this may be a coincidence, but again, so what I mean to say is, if the heap gets exhausted, it gets terminated, and it shows probably you have seen this. Is it now visible? This part. Hello.
Yes, sir.
So can you see that I took some snaps? It is 27.7, and then memory getting utilized 35.0. So gradually it increases the memory consumption of this particular program, which is a more memory hungry code than a CPU. So you see the CPU is not that much consumed, but the memory is getting consumed. But the rest of the codes, they are just having an infinite loop, no memory consumption. But in this case, memory consumption increases with time, and at some point of time, it just fails because the heap gets exhausted completely. And you see that this particular program is using a lot of virtual memory also, right? Can you see the difference? Because it is more memory intensive code compared to the rest of the but all are known as a.out because it was executed as ./a.out, but the contents of this a.out and this one is not the same. Is that part clear? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
So this is, so you should all try this and see that how it works. Okay, so these are the few things that I discussed in this class, and I think let me stop the class here. In the next class, I think I'll be talking about a bit more about the virtual memory and some of the concepts, and then I'll be talking about this one. Yes, so these will be the topics. So the different system calls, the wrapper functions and all, and the basically the use of the fork system call. So we'll see that how the fork and how the zombie process is created, and you can see that the process status gets changed to Z. That is something different, zombie. Okay, and then there are certain issues that which gets created because of file sharing. We'll see about that. And this is the book by Maurice Buck. So Maurice Buck, so this process state transition diagram or the process states, these are the few defined states in the UNIX operating systems and the different transitions. Okay, so these we'll be talking in the next class. And you see the kind of relation between the actual status and the theoretically defined status of a Linux process. Okay, so these things we'll be talking in the next class. You can try one small experiment. So meanwhile, I would ask you to say combine. So if you run a ps aux or a ps hyphen ef, so from that, combining both of these two, you can extract many useful information of a process during its lifetime. So how much memory is utilized, how much CPU utilized, who is the PID, who is the parent process, what is the parent process ID, what is the child process ID, and all this. Okay, so I would ask you to execute these commands and dump the output in a file. Okay, and then you process that file to extract this information. I'll give the formal assignment on this. And another one you can try as an experiment, that you write a simple code which opens a text file and it will write something from that file. Okay, so what it will write, say there is a value, so it will just read from the file. So a file which has got say 0 initially, it is initialized to 0, and then the program, what it does, it reads from the file, updates that value and writes it back. Got the point what I mean? Hello?
Yes,
Just a minute, let me just explain it and then let me see how many of you have checked it. And so this is, so what I mean is there is a program that you write which will open a text file, say some XYZ, in a read write mode. Okay, and then it will read the contents, it will increment after, so it will say maybe fscanf, it will read the file and it will, whatever value it reads, it will increment that and will write it back, so fprintf. And this file is a particular file, so this is the file xyz, and where it is in the hard disk, because any file is stored in the hard disk. So this is a process, this is a program that you wrote, you have compiled it as erout. Okay, and then after you have compiled it as erout, you are running it from the shell, say ./erout ampersand ./erot. So you are creating multiple copies of it. That means there are multiple processes which got created, say P1, P2, P3, user processes, user process P1, user process P2, user process P3, and they all will, the intention is they would like to read. So initially you write here 0, so they will read the value, increment it and write it back. So if this reads, it will write here 1, and after that if this process is scheduled, so the source code is the same, so this will again read 1, update it and write here 2, and then after that if the scheduler schedules this process, it will read 2 and update and write here 3, like that. Are you getting the point? What need to be done? Say for example this, so there is a loop, there is a for loop for this process, like read, update and write back. So if it does for 1,000 times, and if you have, so if you have spawned 3 user processes out of it, so what do you expect if it starts from 0 initially? If it starts from 0, after the end of all these 3 processes, what value do you expect here in the file?
So 3000.
Any other answer? Got the question? I mean, this is very simple. I mean, too trivial to understand, but is that clear what I meant? Is the problem clear?
Yes, sir. Yes, sir. Yes.
So do you have a different answer, or you all stick to that 3000?
Sir, it can have a different answer, as if context switch is done between the processes, then different answer will come, sir.
Why different answer? So what can be the answer?
I'm not sure about my. There will be lots of answers, sir. Can be
I mean,
plus.
sir, for loop can be divided into sub.
Sir, incrementation is done 3000 times, so obviously 3000 will be the answer.
3000. So it is
Doesn't
guaranteed
depend
3000.
on.
Is it guaranteed to be 3000?
So
Okay, so
according to a log.
so it's better you try it and feel it what happens. And if you find that it is 3000, I mean, if you are convinced, so just increase the value to 10,000 and see that whether it is 30,000, like that, right? And you may create multiple copies of it, 3 or 4, and see that whether the end value, the final value of that, because the text file you can just open it and check what value it is there. So whether it is exactly 3000 or 30,000 or 40,000 as it is required, or it is, so will it be more than 3000? Can it be more than 3000 by any means?
No, sir.
Can it be less than 3000? by any means?
Yes, sir. It should be less than
No,
3000.
it's not should, but there is a possibility.
Yes, sir. Yes, sir.
So,
Possibility. Yes.
like feel the possibility. I mean, feel that it might happen, and then try to
Yes.
come up with the explanation that why it is happening so. And there will be remedies for this, but let us have a feel of it and see the problem. So in the next class, I'll see that what we have observed, and then what answers you might come up, explanations you may come up. Okay. So that will be the small task, but you should go through the ps command and the different shells, shell commands and all. Try to install the ubuntu in your windows machine if you are having a windows machine. So try to do these things meanwhile. Hello.
Yes, sir.
Yes, sir.
Yes, sir.
So I'm not giving any specific assignment, but so try to start things, and by next week I'll be having I'll give the first assignment set. If you have any questions, you can ask me, otherwise I'll leave. Hello.
No, sir, we don't have any question.
Okay, tomorrow there is a class scheduled from 10. The Animesh is supposed. So I'll take instead of Animesh. So tomorrow I'll take a class, first half.
Okay, sir.
It starts
Okay.
from 10 to 10:45. No?
Yes, sir.
Yes. So tomorrow I'll take a class.
Yes, sir.
But I would request all of you to install Linux, some form of Linux in your machines. Otherwise,
Sessional class. Tomorrow will it be theory class or sessional class, sir?
yeah, it's difficult to create boundaries. This sessional, this, so we'll have classes. That's all. So definitely you can consider it to be. It's in the theory slot, so you can consider it to be theory. Any more questions?
No, sir.
Okay, then I'm leaving.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.